So when you see the word inequalities, we no longer have an equal sign. Okay, we will only have less than or equal to, greater than or equal to, less than, greater than, or less than or equal to, greater than or equal to, okay, instead of the equal sign. Inequalities, okay, they not only deal with the points located on the line, but they also the points on either above or below the line. Okay, so we're not just dealing with a line itself, we're dealing with a whole area. So we're going to have to shade the area above or below what we call the boundary line. So the inequality negative 2x plus 4y, watch this, right? There's the inequality right there, is less than 16, would have a boundary line of negative 2x plus 4y is equal to 16. What's the only difference between these two? One has an equal sign, one has the inequality symbol, right? So this inequality has the boundary line, so that's why we're still going to have to graph lines. This is the boundary line that cuts the panes in half. Not in half, but it cuts the graph and has two different panes. Okay? It splits the coordinate plane into two panes. You can probably make a rapper name out of that one, right? Instead of Tupac, two panes or something. And so then it's shading. These units we will shade using regular or reverse shading. Okay. Sorry, I want to make a note. If panes is weird, right? Just say regions. Into two regions. A line will cut it into two regions. So regular shading to start, okay? Pay close attention to this. We're going to start with regular shading, and then I'm going to quickly transition to reverse shading. I'll explain to you why I use reverse shading after we've done a few more examples, okay? It will make sense after we've done this. So let's say I use a red pen for my boundary line. Have a ruler. You need a ruler for this unit. So we shade, when it's regular shading, we will shade the true region. Okay? So just cut this thing, this coordinate plane, just make your boundary line like that. And let's make a copy of that. We're looking at the same graph, just from a different perspective here, and then make a copy of this line and bring it over to this side. Every single time, guys, every single time you have a line, you're going to have a true region and a false region. Okay? So let's say in this particular instance, we figure out that everything above the line, the boundary line, is true. And so what do we know about the bottom part? It's false, yeah. You can't have both true. It doesn't work like that. So the same is true for this one on this side, okay? True, false. If we're using regular shading, we will shade the true region, okay? So in this case, just grab your ruler. That's the best way I know how to do it. Is just have your ruler as the boundary, right on the boundary line, I should say. And so everything above that line is shaded. Okay? If we use reverse shading, we're doing the exact opposite. We're shading the false region. So you put your ruler on the boundary line, and you just shade below. And don't just give it a light shade, because we're going to have labels and whatnot in these regions, and you don't want to cross them out. You want to be able to read what you wrote on there in terms of labels. Both of them, though, did the true region change, though, regardless of which shading we used? The true region did not change. It's still the same. Okay, so you gotta look for that. I'm also going to give you a little heads up already. Sometimes true is also known as the solution region. It's the same thing. true is the same thing as solution. So we need to get the shading out of the way. I'm going to go reverse shading quite often down the road. Textbook only has regular shading, but we're not using a textbook, so that's okay. We're just going to ignore that for now. So dashed versus solid boundary lines. Okay, very important to know that one. If you have the symbols less than, greater than, no equal sign, you use a dashed line. And what does that mean? The points on the line are not included in the solution. So let's say we're just going to have a boundary line here. And just make it dashed. So let's say in this instant we're going to have to determine this, where the true region is, but you have the true here, and we're using regular shading, of course, for this one. Let's say you have, this point is 2, 2. This would be a solution. Why? Because it's in the true region. If you had 2, negative 2, a solution. Would 0, 0 be a solution? The origin? Yes, because it's in the true region. Okay, so any point that is in the shaded area, which is the true region, is a solution. I want you to label this one right here. 0, 2. Is that a solution? It is right on the line, and the line is dashed, which means that 0, 2 is not a solution. Because it's on the line. Okay. Negative 4, 5, let's do this one. Not a solution. So I'm just going to go not. Okay. Not. So the boundary line is dashed, which means anything that's on the line itself will not be a solution. When you have the equal sign, then it's a solid line. That's how we know that everything on the line, and so points are included. Okay. So I'm just going to try to copy this one. So just try to put your ruler on it and just slide it over to keep that same slope. Oh, this one can be solid. Right? True. And then applied, everything we do always ends up in word problems. Okay? Probably noticed that by now. You either love it or you hate it, right? Is a solution. So in this case, 0, 2 is a solution. Here is not a solution. I want something that stands out. So I'm going to grab a different highlighter, and I'm just going to mention that here 0, 2 is a solution, and here 0, 2 is not a solution. That's the main point of this little slide there. All right, 18. Some rules here when working with inequalities. We work with them the exact same way as equations, except for this is a very important rule you need to remember. When multiplying or dividing by a negative, we flip the symbol. And I will show you once why that is. Okay. is this statement right now true? If you read it like this, is 2 less than 5? True. That is true. Actually, inequalities are always kind of asking a question whether or not this is true. Okay. Let's multiply. Let's take the 2 and we multiply everything by -1 or divide by -1. Let's do that. I'm going to use a different color. Let's just assume we're going to divide this side by -1 and the other side by -1. 2 divided by -1 is -2. 5 divided by -1 is -5. If I were to keep the inequality symbol the same, pointing the same way, is this statement true? This is false. Okay. Therefore, right? So flip inequality symbol. So we will, from now on, when we multiply or divide by a negative, we will have to immediately flip that. Okay. So correction. -2 is greater than, I'm going to have a red pen for this one. We're going to face it the other way. Okay, so from that way, the other way to -5. True again. Okay, so flip the inequality symbol whenever you divide by negative. This is probably a very good entry on your study sheet because students forget this all the time. Just flip it. Yeah. What do I want to do here? Determine the true region. I'm going to show you the shortcut, and then I'll do the test point method. So the graph of the inequality is given below. This is an example of regular or reverse shading. Okay. How would you know? I will tell you this. Rewrite into y equals mx plus b. And I know we don't have equal signs here, but we're still going to treat it like an equation. So -2x plus 4y is less than 16, correct? That's the original. I'm just copying it down here. Let's bring the 2x over on the other side of the inequality symbol. What do you think happens to that 2x? It turns positive, that's right. Do I need positive 2x? I'll just do it, why not? Doesn't hurt. So when you're bringing things over, nothing happens to the inequality symbol. And now we need to divide by 4. Are we dividing by a negative? No, right? So we don't need to flip that inequality, correct? Let's leave it, okay. Less than 2 divided by 4, that's just 1/2, right? 16 divided by 4 is 4. And I'll just tell you this. Since y is less than, okay, the true region is, what would you say? Just if you had to go by intuition, y is less than, would you go below the line or above the line? If it's less than. If it's less than, below the line is the true region, okay? Less than, below, right? Think of it that way, is below, okay? That's the easiest way to figure out where the true region is. So this is the true region. So since the true region has been shaded, what kind of shading is this? It's regular. Okay. So that's how it goes. The inequality tells you where the true region is, right? You determine that, and then the shading, that you'll determine at that point whether this is regular or reverse shading. Okay? The shading doesn't tell you where the true region is necessarily, it's the inequality if you have it. Okay. So this is the shortcut here for you. Let me see here if I'm going to say something about it. If you have the isolated form, if you isolate it and you have y is less than or equal to, the true region is below. And this is what I do. I go true with an arrow down. That's going to be our cue for saying the true region is below. If it's y is greater than or equal to, the true region is above. I'm going to circle these ones, the little like a little legend here, right? This is when you have diagonal or horizontal lines. When you have an x, which way does the boundary line go when it's only x? It's vertical, right? There's no above or below. There's only left or right. So I will, on top here, I'll say vertical boundary, okay? Make a note of that. That's a vertical boundary line. I'm going to give it a color here, okay? So in a sense, you know, you can actually, most of our cases are going to be here. Most of our cases are going to be diagonal or horizontal. But then sometimes you're just going to have an x. Okay, that's a vertical boundary line. So if x is less than or equal to, what do you think, left or right? Think of the x-axis. Where's the smaller? Is always to the left, right? So this would be left. So true is to the left, like this. If you isolate and you get x is greater than or equal to, the true region is going to be to the right. That's, I think, all you need on your study sheet. Just this one right here, this part. The part that I'm about to give you here is just to give you a better idea if you walk through. So let's say you have your coordinate plane and you graph this thing, okay? And you end up seeing that the inequality, if you rewrite it as less than, we would shade here. Sorry, not the shading. Not the shading. It's just the true region is there, okay? Let's just focus on the true region. My bad. So there, in this case, the true region is here. Some students have a hard time saying where is above and where is below, okay? So you're gonna have to kind of walk through that a little bit. So what if you have a line that goes this way? Where is below on this line? If my pencil is the line, below is above it, it'll be here, right? Somewhere in here. So this is true in this case. Above, let's switch it up a little bit. I'm gonna throw in a horizontal line there. If you have a horizontal, the true region would be here somewhere. Above it, right? Let's have one go in a slant like this. The true region would be above the line. That's what matters there. Special cases, I'll just have one for each. That's all you need. I'm going to use a red pen for the... So let's say you graph your line, right? Just like before. Let's say it's x is equal to 5. Your line would be right here. That's your boundary line. And the true region, if you end up with an inequality where it's less than, the true is here. Okay. On the other hand, you could have a boundary line that's dashed. So I'm mixing it up so you You're not thinking it's always solid. Okay. The true region would be to the right. These diagrams, I don't know, I don't think you need them on your study sheet. You can look them up here. But make sure you add this to your study sheet, the first two rows. Okay? All right, now we're ready to graph. Or not. Or not. It's not going to happen. I'm going to stop here. Time flies.